All right, so let's start.
My name is Wilson Santana and I'm an EMEA Technical Trainer for Amazon Web Services. In this video, we are going to have a quick introduction to the AWS Elastic Beanstalk service. We are also going to be discussing the components of the solution, and we are going to have a demonstration of the product and its benefits and features. Let's think that you are a developer of a web service. You may not be actually worried about developing the servers, developing the whole administration of your system, and actually administering everything behind the actual development of your service. So, you are probably wondering, how can I quickly get my application into the cloud? How can I quickly have the whole environment ready so I can start developing my system? The answer to that is AWS Elastic Beanstalk. But how AWS Elastic Beanstalk actually works? Which are the benefits and features of the system? It's a platform as a service, and being a platform as a service, it means that you have the whole infrastructure and the whole platform created to you, so you can simply put your code over the system as required. Also, it allows a quick deployment of your applications. Any code that you have previously written on some specific languages can be simply placed over the platform that you have. Also, it reduces the management complexity. You don't need to worry about managing the whole system. But if you wish, you can have full control over that. The control over the system that has been developed to you allows you to choose your instance type, or according to your needs, choose the database that's better to your needs. Also, it allows you to set and adjust auto-scaling according to your needs. Besides, it allows you to update your application, access server log files, and enables HTTPS on load balancer according to the needs of your application. It also supports a large range of platforms. It goes from Packer Builder to single container, multi-container, or pre-configured with Docker. It supports Go, Java with Tomcat or SE, .NET on Windows, Node.js, PHP, Python, Ruby. So depending on your skills, on the idea of developing your web service, you can simply write your code and use Beanstalk to deploy your environment as you need. Elastic Beanstalk is going to provide you all the application service level, the HTTP service, operational system, language interpret, and the host. The only need that you have then is create your code, deploy it, prepare it according to the needs of your service, and then you're simply going to use the application as you need. With that, you're going to have something really easily implemented. Also, the steps to deploy and update your service are based only on the creation of your application. After that, you upload the version to Beanstalk that then launches all needed environment in the cloud according to the needs of your application. After that, you can manage your environment, and if you need to write a new version, you just update the version. And deploying that, you can manage that. With this cycle, it becomes really easy to update your application as easily as you deploy it. Let's go now for the product demonstration, where the features and benefits from Elastic Beanstalk are going to be then demonstrated. Let's consider a real case scenario where you have created your web service and you have written this service, for example, in Python, and all your code is here. It's a real simple code where you have your application properly zipped. What you need to do now, how can I actually have the environment and make it available worldwide to have my web service properly presented to everyone around the world? With Beanstalk, this is something extremely straightforward. The only thing that you need to do is actually start service. Then we go to our dashboard and look for a last beanstalk. There, what we need to do is create a new application. We just enter then our application name. In our case, let's enter the name Beanstalk Demo and a simple description. This is a demo. The only thing that you need to do right now is create the environment for the application. What do I need to do now? Create one now. This is a web server environment. If I need to run a work application processing long-running workloads on demand or tasks in schedule, I could move to working environment. But in this situation, the only thing that I have created is a simple web server environment. I go here and
Okay, so let's understand what is a worker environment. A worker application that processes long-running workload on demand or performs task on a schedule. In a worker environment, each instance runs a daemon process that reads messages from an SQS and relays the content of the message in a post request to a path that you configure. Okay, in one word, if I tell you this is a cron, kind of a cron, right? And it just runs and it can do 8 particular tasks, either based on time or based on an event, right? So in this event, you have a Amazon SQS queue, which is already integrated to it, right? So you can whenever a new message comes to SQS, I don't know how many of you know what is an SQS. Maybe in one of the further notes I'll tell you. Okay, so if a message comes to an SQS, this particular daemon thread will trigger. It will read the message and it's going to do some performance, some action, which is saying messages in a post request to a path that you configure. The post request can be an API gateway. Yesterday we learned about API gateway and Lambda. Okay, I can give a path of an API gateway, and that API gateway in turn will call Lambda and do something with that message that has arrived. Okay, so this is a worker environment. It's a worker. It's continuously keeps working for you and doing something in the background. Okay.
Select web server environment. And I enter then some extra data according to my needs. I'm going to enter here any domain that I would like to create manually, but I can leave it blank for auto-generated value. That's what we're going to do. A description. This is the demo. And here we have some options. We have some pre-configured platforms with the language that we have already mentioned as support. In this case, we are going to select Python because my application has been written in Python. We also have the options here of running a sample application. So if you want to use your account right now, even without an application, to play with Beanstalk, it's quite straightforward. Just open Beanstalk and run a sample application. In this case, we have our code that has been written in Python. So I'm going to upload your code, and then I'm going to upload that. I'm just going to choose the file that's a local file that I have. But if I have this file available in an URL, I can simply select a public S3 URL here. Choose the file. Here is my file in zip format. And I then upload the file. If I want to modify any default configurations, I can simply go to Configure More Options. In this area here, I am allowed to choose between the low cost, which are the free tier defaults, or I can go for high availability or custom configuration. In our example, we are going to keep all of this at the defaults, but in this example here, you can see how flexible it can be after you create your defaults. Let's just create our environment. What the system is doing right now is creating the whole environment, all the instances which are required, all the networking environment. If your application requires a database, if your application requires something extra to be deployed in high availability, all the steps are going to be then performed and displayed here in this log. This is something that can take about 5 to 10 minutes depending on the size of your application, sometimes even more. To speed up that, I have already created an environment with the exact same code that you can use, and this is what you're going to see when everything is ready. When everything is ready, you're going to have a dashboard like this showing what you have created and allowing you to upload and deploy new versions. But most important, you're going to have this URL. This URL is the URL that has been created to your application, so anyone can access that anywhere. Clicking on that, you're going to see that your code has been deployed and has been created according to your needs. Besides that, all this control here can also be performed using command line interface and scripts. With that, it's clear that the environment that has been created is supplying my needs according to the code.
So what you just saw is for people who do not know how AWS works or who do not know how to customize AWS for them. Okay, and there are many such people who use Beanstalk. Okay, you don't have to worry about configuring autoscale or worry about configuring databases or your network or VPCs or subnets or load balancers. None of them you have to worry. You will just come here, click next, upload your code, and click next, and everything is ready. Okay, backend, the entire infra is managed by AWS. So this is this is why I said this was the platform as a service on the AWS infrastructure as a service. And I'm sure anyone can guess that what is running in the background is a CloudFormation template. Okay, based on whatever you're giving inputs in the front end, the CloudFormation template takes those inputs and creates an environment. That is all what Beanstalk is.
And you don't need to actually worry about the architecture of the system beforehand. So it makes it really easy for your developer to go create the code and make it available in a real scenario.
Yes, tell me. Was I audible all the while? Am I audible?
Yes, sir. Yes, sir.
Okay. Thank you. What is the answer? Yesterday we saw Lambda.
Upload your code.
Play for estimated compute time, upload your code. So definitely we are not deploying an OS image, we are not putting EC2 instance. Yes. Upload your code is one instance, pay for estimated compute time is another one, right? So let us see. Oh, sorry. So let's see if pay for estimated compute time is the answer. So that is incorrect. Why is it incorrect? Because largely in AWS, you do not pay anything upfront. Okay, so similarly, if you remember yesterday I explained to you how the costing works, right? 20 cents for a million. Did I say 2 million or a million? God knows, whatever I said. Okay, for invocations. Okay, and then for every million you get another 20 what you pay. So you really don't know what you're going to pay. So what you're going to do is just upload your code. You upload your code and start working. That's it. Actually, what I'll do is tomorrow I'll call Lakshmi and she will give you a quick demo of how to write a Lambda code.
Welcome to this introduction to Amazon Simple Notification Service. My name is Wilson Santana, and I am EMEA Technical Trainer for Amazon Web Services. Let's start our discussion with a simple question. Let's imagine that you are in a situation where you have microservices which need to talk to each other and need to be decoupled. Or if you have some event that you simply need to send an email to administrators or system developers informing or some event that happen in your architecture. How can you easily do that in Amazon? The answer is Amazon SNS, the Simple Notification Service. What is actually Amazon SNS? This is going to be discussed in our presentation, as well as its characteristics and usage, and a demonstration of the service. Let's have a service introduction for SNS. What is Amazon SNS? One of the most important characteristics is that it's a flexible, fully managed pub/sub messaging and mobile communication service. Besides, it also coordinates the delivery of message to subscribing endpoints and clients, therefore enabling you to send different information to different subscribers. It's also easy to set up, operate, and send reliable communications. Also, it allows you to decouple and scale microservices, distributed system, and serverless applications. Amazon SNS allows you to have pub/sub messaging, rate and send reliable communications. Also, it allows you to decouple and scale microservices, distributed system, and
So decouple and scale microservices, distributed systems, and serverless application. Okay, decouple distributed systems. So basically the SNS is a notification service. An event, suppose there are two Lambda functions, and let's say I write a code saying whenever the code just accepts two input values, and I write a code saying if the addition of those two input value is 4, send a notification. Okay, and when the notification is triggered, there I write a rule saying if the value comes as 4, invoke this particular Lambda. So basically I'm completely decoupling the process and orchestrating the entire inputs and output and actions based on the output using SNS notifications. Notification, as you all know, I mean all the guys who are into technology will know, is the base essence of doing anything on AWS. Right from CloudWatch to monitoring to whatever, notification is a central of the AWS core system.
serverless applications. Amazon SNS allows you to have pub/sub messaging for different systems in Amazon, like AWS Lambda, HTTPS, and Amazon SQS. Also, Amazon SNS mobile notification.
Okay, so now let's understand what is SQS. We have understood what HTTPS maybe. We are, when we're talking of HTTP or HTTPS endpoints of REST, which we were discussing earlier during this training. Okay, SQS, the full form is Simple Queuing Service, queue service. Okay, and just as what the word says, it is a database that maintains queues, right? So what you do is, I'll write a program and I will send a message hello 1. It will add it as a queue. Then I will say hello 2. It will add as a queue below hello 1. Okay, so this is called so there are two kinds of queues, LIFO and FIFO. That is why LIFO and FIFO. LIFO is last in, first out, and FIFO is first in, first out. Okay, so if I use the FIFO queue, that is first in, first out, if I try to, now I'll write a program that will read the queue. Okay, this side someone is publishing in the queue, I'll write a program this side which will keep reading the queue. So when I says give me all the new notifications, I write a thread. The thread moves and it gives me all the notifications. The first one will be hello 1, the second will be hello 2 if I'm using a FIFO queue. Right? Now once I get the notification, what do I do with it is up to me. Again, I write a logic there. If it is hello 1, send it to Japan. If it is hello 2, send it to America. Whatever. I mean, I can just write it. So the good part of this is, where do you use such queues? Again, decoupling. So when you suppose you have okay, so let's take the example yesterday which I was showing in IoT, right? So in the IoT we said that there are switches and Wipro would have sent more than 100,000 or 1 million switches across the country. Okay, and all of these switches are now transmitting data for chatting to AWS. So let's say, for example, all these 1 million device send the data every 1 minute. So what will happen for 59 seconds? You will have no hit. On the 60th second, you'll get a million hits. How will your infra handle that 1 million hits coming more or less concurrently? Right? So what you do is you use things like SQS, or you'll use Kinesis and all. Okay, Kinesis or Kafka, two words you remember or write down. You can just do some googling around. What is Kinesis? What is Kafka? Think about SQS. If SQS is a river, okay, Kafka or a Kinesis is an ocean. Okay, so if at per second, if I'm getting 100,000 hits or a million hit in a second, I would use Kafka. Sorry, I've used Kinesis from AWS parlance, right? I will use Kinesis. Okay, it will open huge queue for me, and it will manage all those 1 million messages that would have come in from different devices. Now I have a backend process which will pick up one by one the messages and keep processing it. Okay, for the account that has come in. So that is what Kinesis does. Kinesis is, in a way, a very big size SQS. Similarly, if the size is smaller, if it is 1,000 or a 10,000 or a 50,000 kind of stuff coming, I would just use SQS, and I will store all those messages in SQS, and using my program which I would have written on this side, I will read each queue and start working on it. What are the programs you will write here? So using what will you write the program here? If you remember in the last thing we said a worker process using Beanstalk. Okay, this side can be a worker process using Beanstalk, or SQS I can connect as an event to Lambda. As soon as a new event comes, Lambda will get triggered. Lambda can go up to 10,000 threads at the same time. It will get triggered. It will process it and say put it in the database. Right. So are there a worker process which keeps pulling or reading it, or a Lambda which is a push? Message comes in, Lambda gets triggered. Here you have anyways. He has shown it. Message comes in, Lambda gets triggered, and the push happens. Okay, so understand this is a very powerful thing. Mostly used in middlewares. Okay, middlewares are like Tibco. They all work on the same concept. You'll have Worksphere MQ series. Okay, IBM MQ series are there. Now they are called as WebSphere MQ. Okay, so they are all a queuing service. Then comes the mobile notifications. They are the notification that you see, basically, which what are they support? I don't know what is ADM. Baidu is there. Google is there. Okay, this must be Apple somewhere. One of these must be Apple's and all. So any notification that comes onto your mobile can be sent via SNS to multiple different mobiling platforms.
Allow you to do similar publishing, but to different mobile systems like ADM, APNS, Baidu, GCN, MPNS, and WNS. Let's go and have a product demonstration so you're going to understand the benefits of the product. Let's work over the SNS dashboard and create a product that allows me to send information to an administrator. How can we work over that? The first step means creating a topic. The creation of a topic allows me to send the necessary information to the destinations that I wish to set. The first thing that I need to do is enter the name of the topic. In our case, it's going to be SNS Demo. Any name at all that I wish to give to that. In this case, it can be SNS Demo as well. With the topic properly created, the first thing that I need to do before I create any subscription, before I send information to any destination, is that I need to go to Topic Actions and check the topic policy. This is where I'm going to set the security of my topic, allowing only specific users to send the information to the destination that I have set. In our example, I'm going to leave it open for everyone to make it easier to generate the data. Right? So in this case, everyone is able to use all the delivery protocols in my topic. Let's update the policy now. The topic by itself doesn't allow you to send any information, so I need to create a subscription. In our case, we are going to subscribe to a given email. So I need to create subscription, choose the protocol as being an email. Look that I have the options here to work as well with HTTP or HTTPS. I can use JSON. I can send that to an Amazon SQS queue, to a given application, even to Lambda or SMS, depending on the region. And then the endpoint, that's going to be the email that I'm going to send. In this case, it's going to be SNSDemo at SNSDemo 233 mail.com. And create subscription. When you do this kind of subscription, the first thing that shows up is the pending confirmation. The pending confirmation means that this information is going to be sent to the email to be later checked out. To speed up our demonstration, I'm going to show to you the results of that. So here is a typical information about that. Note that I just received the email asking to confirm the subscription as well. So I can come here and confirm the subscription. With the subscription properly confirmed, I can just refresh my screen and notice that now I can send information to this email and I subscribe to that. Let's test the service and see how it works. To test that, I'm going to use an S3 bucket. S3 bucket can generate information to the SMS topic as I need it. So I'm going to use this bucket that has been previously created. And at this bucket here, I'm going to set up some properties that allow me to enroll to a given event. In this case, I already have a notification set to a given event. I'm going to remove this one and add a new one. In this case, it's going to be my SNS Timo. And every time that an object is created or deleted, I'm going to send information to an SMS topic. In this case, exactly the SMS topic that I just created. And then I'm going to save it. So every time that an object is deleted or added to this bucket, an information is going to be sent to that email that has been subscribed in SMS. So I'm going here to check my bucket again. And for example, I can delete this object here. So after you deleted your objects, an email is then going to be sent to SNS. We are going to have this email here displayed to you with information about the objects that have been deleted, or if you add a new object, a similar email is going to be displayed here as well. Note here that we have records with all the necessary information about the event in S3. And with that, we have all the parameters involved in that as well. This information here can be later used by any script that could get this information and add this to a database, or it can even be used to start other process or a Lambda function, for example. I hope you enjoyed and learned something from this presentation.
Hi, I'm Wes Gruber with AWS Training and Certification. Welcome to Amazon CloudWatch. In this video, we'll give you a brief introduction to the service, go over some common use cases, and then we'll run through a short demo and show you how it works. I've been with AWS for 2 years, and I'm currently responsible for training our enterprise customers on AWS services. As part of the training and certification team, I help our customers better understand how to choose and use our products and services. I teach everything from architecting on AWS to DevOps, as well as security on AWS. In this video, we're going to introduce you to Amazon CloudWatch. Specifically, we're going to give a brief introduction, an overview. We'll go over some common use cases for the product, and then we'll do a short demo and show you how it works. So what is Amazon CloudWatch? At its core, it's simply our monitoring service that allows you to monitor your AWS resources and the applications you run on them in real time. Some Amazon CloudWatch features include collecting and tracking metrics like CPU utilization, data transfer, as well as disk I/O and utilization. We can also monitor services for cloud resources and applications. Additionally, you have the ability to set alarms on any of your metrics that you'll send notifications or take other automated actions. This is really one of the core features of CloudWatch that makes it an extraordinarily powerful tool. The ability to automatically react to changes. You can send an existing system, application, and custom log files to CloudWatch logs that can be analyzed in near real time. Overall, this allows you to gain a system-wide visibility into your resource utilization, application performance, as well as operational health. Amazon CloudWatch architecture includes resources that support CloudWatch, such as CloudWatch metrics. The basic metrics include metrics such as CPU utilization, as well as status checks. Custom application-specific metrics can also be involved for recording from available statistics within your application. All these things are reported to the AWS Managed Console. They also can be logged and sent off to trigger an Amazon CloudWatch alarm. CloudWatch alarm can either send out a notification through email or SMS. Additionally, it has the ability to trigger an auto-scaling event, which, as you're going to see in our demo, is a very powerful service. Some common use cases for CloudWatch, of course, are to respond to your state changes in your AWS resources, automatically invoke a Lambda function to update something such as DNS entries when an event notifies that EC2 instance enters a running state. You can also direct specific API records from CloudTrail to a Kinesis stream for detailed analysis of potential security or availability risks. You also have the ability to take a snapshot of an EBS volume on a schedule, or to log S3 object-level operations using CloudWatch events. Some of the components that make up Amazon CloudWatch include metrics, alarms, events, logs, and dashboards. We're going to talk about each one of these components individually. CloudWatch metrics. This is where the data about the performance of your system comes from. It really represents a time-ordered set of data points that are going to be published to CloudWatch. By default, several services provide free metrics to your resources, things like EC2 instances, EBS volumes, as well as RDS DB instances. But you can additionally publish your own application metrics for an additional fee. All these metrics are loaded into your account for search, graphing, as well as activating alarms. CloudWatch alarms watch a single metric. It can perform one or more actions based on the value of that metric relative to the threshold over a number of time periods. So that action can be an EC2 action like stop, start, terminate, reboot. It could be an auto-scaling action like launch an auto-scaling configuration and add more instances to my application pool. Or it can just be a notification sent out via SMS topic. It invokes actions for sustained state changes only. So here's an example of a CloudWatch alarm. Let's say, for instance, you want to track CPU utilization on your EC2 instance. And in this case, if CPU goes over or greater than 60% for 5 minutes, that's the threshold that we set. It can trigger things like if an RDS instance number of simultaneous connections is less or greater than 10 for 1 minute. Or if we have we could monitor an elastic load balancer and say if the number of healthy hosts is less than 5 for 10 minutes, then go ahead and trigger an alarm or trigger some action. So the CloudWatch alarms can measure a single metric and perform one or more actions. It could stop, terminate, reboot, or recover an instance. It could scale an auto-scaling group in or out. So Remember, we always scale out to meet performance demand, and we scale in to save money. So we want to think of that in terms of going both directions. Or it could just simply send out a message to an SMS through email, HTTP, or through SMS to notify you if that an event has occurred. CloudWatch events are your near real-time stream of system events that describe changes within your AWS resources. It uses simple rules to match events and then route them to one or more target functions or streams. It can be aware of operational changes as they occur, and also respond to operational changes and take corrective action as necessary. Additionally, you can also schedule automated actions that self-trigger at certain times using a cron job or RAID expressions. Here's an example of a CloudWatch events. So in this case, how do you detect and automatically revoke unintended IAM access with CloudWatch events? So I have an API action that makes an API call for a certain event. CloudWatch events is going to record that, and it can deliver a rule that matches in a Lambda function. In this case, if that particular event for an authorized user happens, we can revoke access for that particular authorized user using a Lambda function. CloudWatch logs. We have a separate video that details CloudWatch logs and goes over CloudWatch logs in much more detail. But basically, you can use CloudWatch logs to monitor and troubleshoot systems and applications using your existing log files. So it can monitor your log files for specific phrases, values, or patterns, retrieve the associated log data from CloudWatch logs, and it all runs based on agents that are installed on the operating system. And of course, we have agents that are compatible with all the supported operating systems within AWS. Amazon CloudWatch log features include the ability to monitor logs from EC2 instances in real time. Additionally, they can monitor AWS CloudTrail events. Remember, CloudTrail events are all API actions that happen within your account. And since everything that basically happens within AWS, whether it's from the console, the CLI, or direct API access, is all API driven. This gives you a full record of who did what when in your environment. So this is very helpful for security and compliance. And of course, you can also archive log data as well for future analysis. Additionally, you can store and monitor your application log files, collect those metrics, and they can be durably stored for a long period of time. They can be visualized by admins through the console, or they can be stored in S3 for access by another service, ingested by another service, or another user or tool. And of course, we can do data processing on that particular solution, look at those through things like a Kinesis stream or AWS Lambda, take further action on a particular metric. The CloudWatch dashboard is really a customizable homepage within CloudWatch console to monitor resources in a single pane of glass, if you will. Even those resources that are spread out across different regions can be aggregated in one place. It makes it a lot easier to visualize them. You can create customized views of metrics and alarms for your AWS resources. Each dashboard can display multiple metrics and be accessorized with text and images however you desire. You can create dashboards by using the console, the command line interface, or by using the Put Dashboard API. Next, we're going to go into a short demonstration.
So basically what you heard is said that CloudWatch is the central alarm, as simple as that. Okay, that alarm can get triggered based on multiple different events that has been fed. Either you can create your custom rules. Okay, you can create a custom alarms. You can say that if my RAM, which is the RAM metrics, if my RAM goes beyond a certain threshold of 60, 70%, 80%, 90%, send me an alert. Okay, so this we call as custom metrics in CloudWatch. Like CloudWatch by default doesn't give you a RAM analytics because AWS doesn't go inside your instance ever, right? So the RAM analytics has to be a custom CloudWatch metric. So similarly, I can write anything. I can just write if the number of hits which has come to my Apache server increases 100, has gone beyond 100,000, send me an alarm. So I'll connect a customer metrics and I'll show that. Okay, so I can do anything with CloudWatch. On any event, I can call it, trigger it, and once it is triggered, I can connect a CloudWatch alarm to Lambda. Okay, or I can connect a CloudWatch alarm to SQS. Okay, or I can just simply write into a database. anything I can do, right? So that is a very powerful feature that connects with any input source, and can also connect to many, not any, but many output sources within the which are available within the AWS environment.
So in this short demonstration, we're going to show you how to create a CloudWatch events rule. So we start out by going into the CloudWatch dashboards, and we're going to slide down to where it says events, and of course click rule. The first thing we have to do is step one in creating a rule is to select an event source. In this case, we're also going to do it from an event pattern. This is where you can build a pattern to match the events. Select the service you want to create and add a custom pattern. In this case, we're going to do it as a schedule. So we're going to create a schedule at a fixed rate of every 5 minutes. So it's basically the same syntax. You could also use the same syntax as a cron job if you're Linux admins out there are familiar with how to do that. Then we're going to log the state of an EC2 instance using CloudWatch events. So the next step is to create a Lambda function that's going to log the state change of events. So we create a rule to run the Lambda function whenever you launch an EC2 instance. Add a target and then choose that particular function. And for the function, we're going to select Lambda function that we created. Next, we're going to set up a CloudWatch alarm for an EC2 instance. So we're going to set up alarm actions with the EC2 CloudWatch tabs under the management console. And if you see the instances there, there's a drop-down button that says actions. And in the actions, we're going to create, we'll go to alarms. In this case, we're going to create a CloudWatch alarm. And the CloudWatch alarm has several different parameters that we can choose from. But in this case, we're going to set up a notification, call it my topic, with the recipients there, an email address, what action we're going to take. And then in this case, we're going to put use basis metric on CPU utilization and create the alarm. We're also going to add a custom dashboard so that we can, in this case, we're going to call it a CloudWatch blog, create that dashboard so it can display just those alarms that we want to see. In this case, we can do line or stacked area to add a graph if we wanted to. We could add a number to display that metric on the dashboard, and then a text block on our dashboard itself. So in this brief introduction to Amazon CloudWatch, we've talked about the Amazon CloudWatch core services, as well as the AWS resources that support CloudWatch, including standard metrics and custom metrics. We talked about some of the available statistics within CloudWatch and how they can be displayed through the Amazon CloudWatch Management Console, or they can trigger an Amazon CloudWatch alarm, which in turn can send out an SMS email notification or trigger an auto-scaling event. I hope you learned a little something and will continue to explore other videos. I'm Wes Gruber with AWS Training and Certification. Thanks for watching.
Okay, so today we will end this here. Tomorrow will be the last session of this. Okay, we'll run these two things, do a knowledge check, and I don't know what is module completion. We'll check it out, right? So the CloudFront is an important concept, though I have talked about it earlier also. Okay, at least we'll get a revision when we do this. Okay, and CloudFormation, you'll understand how to write automation templates for your AWS workloads that you can work on. So let's meet tomorrow at the same time, and we'll end this particular session. What do we have in transcripts? Okay, this transcript of this, what are you guys saying? Fair enough. So thank you for today. Tomorrow we'll connect again and we will look forward. Thanks a lot.